Hello and welcome to the tutorial for the Scales of the Universe simulation. This is my version of, I'm sure if you're a physics teacher, you've seen one of those powers of 10 YouTube videos where it zooms out. Or like first it, yeah, I think mostly they zoom out. It's like a person zooms out a city, zooms out like a country, zooms out, there's the Earth, zooms out, and it keeps going out and out and out, and eventually you're at like a galaxy, and then, you know, the size of the entire universe. So this is my version of that, although it doesn't have dramatic theme music like those videos have, so those might be better. But I made my own version. In the top left, if you like, it keeps track of the power of 10 meters. And it, by default, starts at the Earth, and you can go, 18 steps. You can actually just skip to the step up here if you want to. But it goes 18 steps down or 17 down, and then, another like 28 up, or however many that is. So if we'll just click each. You can adjust the speed at which they transition if you want. So, we go to a white dwarf like Sirius B. I'll just do this quickly, but it's, you can savor it a little more if you use it. Mars, 0.53 radius of the Earth, Mercury, and this is the Moon. And then this is how small a neutron star would be if it was the Sun. One solar mass, about 20 kilometers. Further on, a black hole, 3 kilometers in diameter. There's the CN Tower from my hometown of Toronto. And we zoom in, and there is a person. And at 1.8 meters, you can see we're already at 10 to the 0 meters. Zooming in, we have a flea. Zooming in more, we have our animal cell. And zooming in more, we have a bacterial cell. And zooming in more, we have a virus. From the virus, there's a protein, there's glucose, there's hydrogen, and then we've got to go 10 to the 3 smaller to a picometer, and then we've got to go 10 to the 3 even smaller to a, a femtometer? And there's your proton. And that's as close as we go. You could... Here, I'll just skip to 18 and we'll just zoom all the way back, and I'll even speed it up here. So we'll get right back to the Earth pretty quick. And now we'll go the other way. Slow it down again. I'll just keep clicking. I don't need to narrate all of them, but you get the idea. Sometimes I'll actually show like a little line to a previous thing that looked huge. And I put a star here for yellow dwarf because we're going to look at it when it turns into a red giant. So there's the sun looking pretty puny. There we go. There's the sun as a red giant, 256 times the radius of the sun, and you can see the sun is not even a single pixel anymore. So we got our bigger and bigger UY Scuti. I think that's the current record holder for the biggest star, or one of them at least. And then we get to the orbit of Pluto, and we just keep going, outer limit of the solar system. I just added this one last year, Ton 618, largest black hole known. That was cool. Read that in the news. Start of the Oort cloud. 1 light year. Distance to the nearest star, Alpha Centauri. 100 light years. At this point, I can't have as many dots as there are actual stars. And so after 1,000 light years, we just kind of zoom out to a picture of the Milky Way here. And then we got this one's actually shouldn't be there. That should be the next closest to the Andromeda. Regardless, local group of galaxies. Yeah, at this point, it's not going to be, of course, anywhere near the real number. If you look at a proper sort of computer-generated visual of Laniakea, it looks incredible, and this is just a bunch of dots. But if we go out further, we get to the observable universe here. And then just for fun, I threw in kind of a multiverse soup at the end. So if you decide to show that to your students, I hope you enjoy it.